Hello and welcome back to the Redis IoT show. It's been a little while since we did one of these, so I might be a little bit rusty. It's also 4th of July today, so our colleagues in the US aren't working today. So I thought we'd have a bit more of a sort of fun day at school and do something a little bit more relaxed and less prepared than we usually do. However, we are going to keep working with the same project that I was working on for the past couple of streams, which it's been a few weeks now. I've had other things that I've had to do. So I'm coming back to this project pretty fresh, as you probably are as well, if you're following along. But if you haven't seen the previous episodes, go find them on YouTube. The link's down there. There's also a playlist for all of my stuff, and you'll find them in there. I'm linking the episodes in the GitHub README as well. So if you follow along with the code, which we'll look at later, and I'll put the GitHub URL up, then you'll be able to find all of the previous episodes and figure out what we're doing and how we got to this point in time here. But let's take a quick look at what we're up to. And also, hello. If you're watching, please do comment. This is a live event, so we would love to hear from you. Especially it's a bit quiet for me today at work because most of my team is based in the US. They're on holiday. So what we're doing in this project that this is, I think, like the third live stream for, is let's bring this onto screen. We've got a Raspberry Pi with a camera, and this actually originated from someone in the community who wanted to know, can I store image data in Redis and do stuff with it? They wanted to build something that I think is going to capture images of birds in the garden and then feed them into something else and classify them. So I was like, yeah, you can. It's just binary data. It doesn't matter. And that's not a very interesting answer. So we built something that demonstrates that. And I've kind of built something like they're going to need, but I've not put it in the garden. It's behind me. You can kind of see it over there. And we'll look at that later. But what I've got is a Raspberry Pi. I'm using a 3B. It really doesn't matter. It just needs to be one with the camera connector on it. I had a 3 around because there's been supply chain issues for about a year now, and it's been hard to get other ones. Those seem to be easy though. I managed to get a Pi 4 this morning, so we've now got an 8 gigabyte Pi 4 for future projects. We've actually got a couple of them. Might do something with clustering or with different Pis doing different things and sharing data with Redis. We'll see. So what we've got here is a Pi project. It's got a camera on it. It's just a Raspberry Pi camera. In earlier streams, we looked at having an old version of that camera and then move to a newer one. The newer one has the advantage of having autofocus, so you don't have to put the thing at a fixed distance from the thing you're taking a picture of. It'll actually autofocus, find it, and then snap the picture like you would expect a modern camera to do. So what are we doing with that? Let's these slides are sort of animated. We're taking data from that camera and some other things, and we're storing them in Redis. So what we're doing is we're storing a timestamp of when the picture was captured. We're storing another value we get from the camera, which is lux. That's like a measure of light. So the bigger the lux number, the brighter the light was. That comes from the camera sensor. We don't need extra hardware. We're storing a MIME type for what type of data the image is. So I'm capturing images in JPEG. The camera can actually do video. It can also do RAW. Look, I went for JPEG because ultimately I want to show these on a web page, and that seems like an easy option. Then I've got that bottom field is image data. That's the binary data for the image. And that was kind of like the question we're answering here from the community is, can you store binary data in Redis? And the answer is, yeah, absolutely. Anywhere that a string is expected, so a Redis string, and we'll look at what that means later, you can put binary data. So we're putting the binary data in there. Redis doesn't care, so you kind of need to remember what you put in there. I'm using the MIME type as a sort of hint or a memo for that. But you could just encode that into your application. You know that that's always going to be a JPEG image, or you know the other one's always going to be video. Then what's happening from there is we had initially a timer, and what that was doing was every so often it would just shoot another picture. And then I built a little Flask application that showed all of these images. And we looked through a couple of ways of building that. We started off by using the Redis scan command and going through the key space and finding all the keys that began with image and were hashes and so on. And then we moved that to the search capability of Redis Stack. The reason we did that was to give us some more flexible searching. So we could look for images within a certain time period or find the most recent however many, or ones where the lux value was between a certain range, or a combination of any of those. So like, find me everything from Tuesday afternoon where the lux was above 120 is the sort of query we could do. And then we built a very, very simple front end that just renders out this information. It pulls that image from Redis like it would any other field, and it's a Flask backend. It just sends it out to the browser encoded as a JPEG image, and it sends the binary data, and the browser knows what to do with it. So in that way, our images get from the little Raspberry Pi through the camera into the database, out of the database into the front end. Then after that, we decided that the timer isn't very clever, because if you're building an event-driven system, like you want to track a bird or something happening, there's a couple of ways you could detect that. One would be maybe it moves and triggers a motion sensor. Another would be it might trigger a break beam sensor, so it passes through a certain pair of points and literally breaks a beam that's between them. And then what I went with was adding to the camera a sound sensor. So we'll have something that when we make a bit of a noise, the camera is triggered. And this thing wires up to the Raspberry Pi. It uses the GPIOs. This is all covered in a previous video. And then that sort of blue terminal block on the sensor there has a screwdriver head. And that allows us to adjust the sensitivity. So it's like a potentiometer. We can dial in how sensitive we want the noise to be. This sensor can be treated as an analog one, in that we could get an idea of how much noise there is, but the Raspberry Pi pins are all digital. So in this case, it's a 0 or 1. So was there enough noise or not? So you use the potentiometer there for the threshold. You don't have a number in your code that is like a trigger number for how much noise. And then we have some very simple code that fires the sensor. So we change the thing from a timer loop to an event loop. We just read the sensor, and if the sensor triggers, we say, hey, you know what, there was enough noise. So that's what we had. I'm going to get rid of Keynote here. And what we are going to take a look at is where the project was really quickly. And I'll just go through what we're going to do today, which is something that should be fairly simple. He says, having not really practiced it much, but raises a couple of interesting points, which is why I wanted to pick up on it. We're going to change the representation of the data in the database, and I'll come to that shortly. But meantime, here's the source code. It's at the URL below. I'll put that in the chat. It should already be in the description for the video, but let's put this in the chat so that you can access it. There we go. So that should now be in the chat on YouTube and on Twitch. This documentation is a little bit out of date, so we're not using scan anymore. We're using search. And here's the Pi with the camera attached. It's now got a noise sensor attached to it at the top as well, as you saw in the previous video. As I said, here's some links to the previous videos. We'll add a link to this one. As you can see, I originally had this scheduled for some time ago, but things have been a little bit busy. So we will conclude this project today, and then I will tidy up all of this documentation so it actually represents the final state of the project. So what we've got is this, and we've got some, here's the front end running. It's just a Flask application. It just shows the images, and it just shows some basic information about them. These images are a lot better than we had with the original camera because of the autofocus, and the lighting's just a lot better on this camera as well. So if you're doing this, I would recommend using the autofocusing camera, which is actually the default one that Raspberry Pi sell now. They stopped selling the other one quite some time ago. I just had it kicking around. So this was pulling the most recent images, I originally had them expiring after a while in Redis. So we're not using up, each image is like 2 MB. So we're not using up that much memory by just endlessly storing images. We are thinking about how we're going to manage them. And I had them expire after a while, but I turned that off just so that we've got a consistent front end for demo purposes. So what I wanted to do today was take a look at how we're representing this data in Redis and make a change to that and sort of look at some of the implications. So I have got over here, I've got my Redis Insight here, and we can see what some of this data looks like. So each of these keys that we're storing contains a hash. So each time we capture an image, we're capturing those things that you saw on the slides. We've got a MIME type, we've got a timestamp, we've got a lux value. And if I hover over here, you'll see a preview of it. We've got the image data, and the image data is binary. It's not a string. So it's kind of on the application to figure out how to deal with this. Redis doesn't actually care. It's not going to enforce any sort of schema or encoding on that. So what we're doing there is just putting the raw binary bytes into Redis and getting them out again. And you can see there's, if I hover over this, you can see there's some representation of a JPEG header in there, and you can see the metadata about the camera that took the image and a few other things when it was taken. So the 19th of May at 3:33 p.m. Those come through as ASCII characters, but the majority of this is data. And if you pull this field, it's about like 2 megs worth of image data when you render it out. So each of these images is quite a high resolution. If we open it in a new tab, you'll see it's 4608 by 2592. They are quite large. The camera is pretty good. And again, size of the image impacts how much memory you're going to use, impacts how long you want to keep those images around before you move them somewhere else, or you decide that you've done all the processing with them and just let them expire, or whatever it is you're going to do. So got all of these in here already. These are in hashes. And one of the things with Redis hashes, so looking at this, is they're a flat map of name value pairs. So I can have something that looks like this: lux, image data, timestamp, MIME type. I can actually go and add some things to it. So I could add, for example, a description field, and I could put a value in there. This is an image of a dog. I don't know if it is of a dog. And then what you'll find is we've saved that, and this particular hash now has this extra field description. These things are schemaless in the sense of just because I added that doesn't mean that this other one has got that, or that there's any requirement for it to have that. Each hash can have a completely different set of field value pairs. It's kind of on your application to figure out what it wants to do with them. And that's okay. And in Redis, it's key value store. So the way that you access things is the key, or how to make the key. So we have image : timestamp at the moment as our keys. And then you basically do hgetAll as a command to get everything from a hash, and you provide it with a key name, and back would come all of your data. We wanted to use search, which is a little bit more flexible. So search is a rare instance in Redis where you do have to have some sort of schema. So all of my hashes here don't have to stick to a fixed schema necessarily. But if I want to search by certain fields, then all of the ones that I want to be considered or to have come back in a search result need to have those fields. So what we did in a previous version of this stream is, let's go to the README here, I think it is. We added let's preview it, it looks nicer. There we go. We added a Redis search index using this command here. And what we said was we want to have an index called IDX:images. We want it to index things that are stored in hashes and whose key prefix is image:. And then we give it this schema. So we said we want MIME type to be a tag field. That's like an exact text match. lux to be numeric because it's a number, and we want that to be sortable, and then similarly timestamp numeric and sortable. Then we were able to write queries to fetch that data back. So our front end works by a query that basically retrieves the first however many images, sends them back to the front end, and it renders them. So what I wanted to do today was, I've already started this a little bit, was look at, well, what if our data model outgrows this flat map thing? What if we've got some other schema that we want to stick with because an existing application understands it? Or what if we want something nested? Or what if we want like repeats of things, so an array of something? And the obvious answer here would be to move to a JSON document. So at the minute, we're storing each hash as, or each image and its metadata as a hash. We could store each image and its metadata in a JSON document, and Redis Stack supports that. JSON's a native data type, and we can store, manipulate, retrieve JSON data in Redis that way. However, there's a little bit of a complexity, because whilst I said anywhere you can store a Redis string in Redis can be binary data, which is absolutely true. We could store this image data in the hash here. We could store it in a set. We could store it in a sorted set. We could store it in just a string data type. We could store it in a Redis stream. There's all sorts of things we can do with it. When we start working with JSON, then Redis rules kind of don't apply anymore, because JSON is a standard and JSON rules apply. So JSON has to be understood by a JSON parser. It has a bunch of different data types. So it has numerics, strings, objects, arrays. You've got Booleans, and the one that's missing there is bytes. So this value here, image data, looks like a bytes value, or well, it is a bytes value in Redis. And that's okay when we're working with hashes, because those map onto other data types in different languages. So in Python, it's a dictionary, and we can tell the Python client, don't decode this field, which is what we did when we were working with it. And then we handle the decoding of it ourselves. So it's a byte array, not a string. JSON doesn't really do that. If you put a raw bytes value into JSON, you're going to get an encoding, decoding error. You're not going to be able to do it. Not a Redis limitation. It's a JSON thing. So as we're working to their standard, we need to turn the image data into something else that we can store in a JSON document. And I think there's a common way of doing that, and browsers support this as well. If you want to just send the data out to them, would be use a base 64 encoding. So we're going to encode the binary data into something that is string safe, if you like, store that in the JSON document in Redis, and then retrieve it. So I've gone ahead and done a little bit of this work beforehand, but the other thing we're going to need to do is change up our search index. So if we go back to our search index here, we were creating an index over values stored in hashes. So we're going to need to change that to an index over values stored in JSON. And then here in our schema for hashes, we give the field name in the hash that we want to index. So MIME type matches MIME type here in this hash, and Lux does, and so forth. For JSON, we need to change those to be JSON paths, which shouldn't be too big of a deal. So we're going to kind of dive in and do that. I've pre-done some of this, and we'll apply it to the source code, and we'll see how we get on. So what we're going to do is basically break the whole project for a little while and then rebuild it on JSON documents. And hopefully at the end of this, we'll have basically the same thing that we started off with, but we'll have changed the data model under here to be more flexible. So we could have depth to our JSON, or we could have an array of tag values. If an image, say we ran the images through some AI and it was like, this has got a cat, a dog, and a bird in it, we could add animal tags in for cat, dog, and bird. And then we could use our search index to say, find me everything that's got a cat and a dog, but not a bird. And that might be closer to what the original community member that asked about this project was looking for. I don't know. So we'll look into that. And also, I've not been doing this for a while. It hasn't happened yet, but let's put the computer into focus mode, because I'm unlikely to get any notifications, but you never know. So what we're going to do is, first off, look at how JSON data works in Redis Stack here. And then we're going to apply that to the application. So let's first off go and look at the workbench here in Redis Insight and clear away some previous queries. Just really quickly, Redis Insight here is a graphical tool for managing data in Redis. So we can view stuff, as you see with the browser. We can write queries. We can use tutorials, and you can actually add your own now. They're kind of markdown documents. So if you've got like a set of things that your team works with, it's a bit like a collection in Postman or something, you can add that to your Redis Insight. You can get this from, I need to update my banner here, but you can get it from the URL down below. But I recently found out we also now offer this in some different places. So if you're on a Macintosh, it's in the App Store. So go look for Redis Insight in there, and you can get it directly like you would with your other apps. It's also available for Windows and Linux and stuff. So have a look at the URL. That'll tell you where it comes from now. But we have recently expanded those options. So let's, here in the workbench, look at how we can create a really basic JSON document to start with. So we're going to do JSON.set. That creates a JSON document or modifies an existing one. We'll call this Simon test. And then I need to provide this thing called a path. So that's a JSON path. And in JSON path, $ means the root of the document. So I'm going to create this at $, and then I need to pass it some valid JSON. So let's try and do a few things. So we've got a string value here. We've got a numeric value here. And then let's do something like attributes, and we'll make that an array of, let's go with cat, dog, bird. Why not? Cat, dog, and bird. And then let's do something like, we can obviously also do a nested document. So let's do, make up a timestamp and something like creator. And that's probably valid enough JSON. So let's try that and hit my play button here. Oh, an expected colon at line 1. Lovely. Where did we mess that up? So line 176. Oh yeah, metadata there. Right, that's better. Let's fix that. End of file. Hey, I'm not very good at this, am I? What have we got? JSON.set Simon test $, and then we've got hello world, count as 0, attributes, cat, dog, bird, metadata, create a Simon. What have I done? That is a very good question. Just double check. No, I've still got a error was passing an object at line 1, column 115. Unfortunately, I don't know what the column number is, but oh, it helps if you close the top level object, right? So we had a sub object there. I closed it, didn't close the top level. That's probably going to be why. There we go. Okay, so OK response means that's worked. So if I then go back to the browser really quickly and refresh this, we should have a key in here somewhere. Oh yeah, I need to be in the right part of the tree. You can tell I've been away from this for a little while. I went on vacation. Right. So we've got a JSON document called Simon Test. And here you can see it's rendered it out for me. I've got hello world. The counter is a numeric value. It doesn't have quotes. I can expand my attributes array and my metadata thing. And you can start to see how this becomes a lot more flexible than just hashes. So once we've got stuff in there, how do we get it back? We can go back to the workbench here and let's do JSON.get Simon test, and then I can provide some paths. So let's do, I want that counter value, and maybe I want the attributes. And what you'll see is it returns back a JSON representation of those things, and we can parse that out. We can also be a bit more specific. So say I only wanted the 0th attribute, which is the first one, so that should be cat. And you'll see what happens now is I'm not pulling all of this extra data back that I didn't need. And then we can also do things like change values. So if I did JSON.num increby Simon test $.counter, let's add 10 to the counter. Then we get a value back 10 because the previous value was 0. Let's do it again and add another 12. And the value is now 22. And then we can go get the entire document. So Simon test $. And what you see now is my counter is now 22 and I've got all of the other things. We can similarly change or retrieve bits and bobs of this array, or if we wanted to put things in here, we just build up longer paths. So I can do, for example, JSON.set Simon test $metadata.creator, and then set that to something else. So I could do it. I think I can even do this. So first name. Let's like change the whole structure of this field. Last name, like that, perhaps. Let's see what happens now. If I do that, then we can we get an OK response. If I rerun this command to get everything, you'll see that my creator is now a sub-object. So again, I can have total flexibility in my schema here. So that's how we work with JSON. Let's just remove this key so that it's not in the way in the future, and clean up the workbench a little bit. So we've got, let's clean up all of these. We've got some images in here from before. That key's gone away now because I deleted it. And our data was flat. So what I want to do is I'm actually going to keep the flat structure because I'm not going to add anything to this, but I want to show how you change this to a JSON data type so that you can have more flexibility in the future. And there's two places in our code that we need to change it. So let's look at VS Code here. There are a couple of scripts. So here in the Pi folder, there's the capture.py. That runs on the Raspberry Pi and it handles the camera and now the noise sensor. We've looked at this before, and what it was doing before was basically whenever there's a sufficiently noisy sound, so whenever that potentiometer in the noise sensor decides there's enough noise, then we go away and we take a picture, and we were storing the image data as a bytes.io object in Python, so like raw. And we were saving that into Redis in a hash. And what I've gone ahead and done on the actual device is change that to be JSON. So we'll look at how this works with a hash, and then we'll look at how it compares and contrasts. So here I was making up a dictionary of all the things that I want to save. So these are my field names that are going to end up being the names in the hash. This one is my raw data. I use .getValue to get a bytes array out of that bytes.io object that we got the data back from the camera in. And this all stays in memory. So we're not writing it to the file system to then read it back into Redis. And then what I'm doing is starting a pipeline, which is a way of sending multiple commands to Redis in one network trip. So it saves a little bit of time. And we're saying, okay, store a hash at whatever the key is. So we've made that up with the current timestamp and the image prefix. And then we're just saying store everything in that data to save dictionary. And then I'm saying I want to expire that. So after a certain amount of time, that's a configurable number of seconds, I want it to be removed so that we're not burning through memory in Redis and not thinking about how we free it up. And then we say pipe.execute, send all of that to the server, stores the image, sets the expiry, waits for the next noise to happen. So the bit of the script that we need to change is kind of in here, but also we need to do something with the data encoding, because remember, with a hash, it's a Redis string. I can store binary data. When I move to JSON, JSON rules apply. So JSON doesn't have that binary equivalent. We're going to have to base 64 encode it to get it into a string safe thing and then store it as a JSON string. So that may incur a bit of a size penalty, but it gives you the flexibility of a JSON schema. So trade-offs. So let's get rid of that banner because that's been up for a while now. And also, thanks very much, Raphael. I'm glad you find this useful. We love to hear back from people. And one of the ways that you can do that is join our Discord. So we have a Discord there at Redis, discord.gg/Redis. And there's all sorts of channels on there. You can come on there and show us your projects or post jobs that you have that might involve Redis skills, or chat with the community, learn about stuff from our online courses. There's all sorts of things. We'll look at that towards the end. So we've got to change this capture script so that it stores things in a JSON form in Redis. And to do that, we need to change the encoding or apply some encoding to the binary data. So I've actually gone ahead and done that on the Raspberry Pi. So what I'm going to do is bring up the terminal here. We've got a couple of terminals. Let's I could get fancy and connect VS Code to this, but I'm not going to. It's easy enough to just secure shell into it. So I'm here on the Raspberry Pi. It's behind me over there with some stuff in front of it that it can take a picture of. And what we have done is use good old VI. We have edited this script a little bit, and it's relatively minor changes to move to JSON. So the one thing that we've done is we used to have this hset command here. So that would set a value in a hash, or it would set that dictionary to be a hash. We've moved that to be a JSON.set. And what we need to do is provide the same key that we would have used. This time we need to provide a path, so a JSON path to where do we want to set that in the JSON document. We're using $ for the root, which you actually have to do when you're creating a new object or a new key. If you were then using JSON set to update things, you would use just the path to the bit you want to update and just the value you want to change, like you saw me do when I overwrote the creator name in metadata with my first and last name. So that is the only change from a Redis commands perspective. But if we left it just as that, what you would find would happen would be this would fail, and it would fail because our image data field used to be binary, or was binary in the hset world. And what we need to do is make it JSON safe. So again, not a Redis limitation, it's a JSON thing. So what I'm doing here is now where I'm creating this dictionary and I've got the image data field, I'm just going ahead and base 64 encoding that, and then decode gets it back to a Python string. And that gives us a big base 64 string of the image data that is now JSON safe. So it was always Redis safe, even as binary. That was kind of the point of the original series of this stream, was can we write binary data? Yeah, you can, but not to JSON documents. So if you wanted it to be binary in Redis, you could, for example, store it in its own key, just store the image data somewhere and then store a reference to that in the JSON document. But that then means you'd have to do a couple of commands to get the data out. So you'd have to go look in the JSON document, get the reference key for the image, and so on. I chose to put it all in the JSON document just to show how that works. So we have to do this encoding here. So that's okay. Not a huge amount of change. And what I'm going to do now is go ahead and run this. And hopefully what we'll see is if I just keep talking and make some noise, it might fire the noise sensor back there. Yeah, it did. So let's stop this and see what happened. So it fired the noise sensor. We created a new image, and that's the timestamp for it. And we'll grab a copy of that. We'll have a look at it in Redis Insight in a minute. And then this, if you remember from previous streams, was like metadata that we get back from the camera. So this is where I'm pulling my lux value from. It's in here somewhere. Where is it? There it is, lux. So I was just rounding it off and storing it. But I dumped out all of this metadata because these are other things that we could store in here. So if we were telling the camera to crop to a certain part of its resolution, for example, we could gather that information. We could also gather information about, I think, the autofocus and so on. But we're not doing that. What we've got now is a fresh image in Redis that hopefully should be a JSON data type. So if I go up here and filter by key, oops, not that, filter by key, and actually remember to copy the key. So let's copy the key, filter by that. So we have a key here, and you see the type of this in Redis Insight is JSON. So this one's still an old hash one over here in this view. See, that's flat. When I click this, we've now got a representation of it. It doesn't look dramatically different, right? Because it's still flat. We didn't put any extra structure into it. But what you see now is the timestamp actually shows as an integer type or a numeric type, as does the lux. And I can go ahead and add more stuff to this if I wanted to. So I could add, description. This is a demo image. And now we've got that. I could equally add, arbitrarily complicated JSON in there. So we've potentially got a better base for a complicated data model now. And what we've got in here is this is now the base 64 encoded version of the image data. So we could send that to a browser as is, because browsers understand that, or we could decode it. So we're now capturing data in JSON format, and we're also setting a time to live. So in 178 seconds, this will disappear. Let's use this as a bit of test data and make sure it doesn't do that. So there's a couple of commands in Redis. There's TTL would set the time to live on this. And we could set that to something very big. We could also just say persist and then that key, which kind of undoes any time to live. So it turns it back into a persistent key. So if I do that and refresh now, you'll see TTL has no limit. So it's not going to go away. So we've now got a bit of temporary test data we can use. And what I want to use that for, and let's just make sure we've got that copied, is to demonstrate the front end a little bit. Excuse me. So we have the front end here. It's a Flask application. And as I showed before, if you open each image, you get just the image. And this goes back to a root in the Flask application, and it requests an image from Redis, reads it, and as you can see, I've slightly chipped my Las Vegas coffee mug there, which is quite sad. You can see that it goes and gets the image and renders it out as, in this case, a JPEG. So it's doing that from the hashes, and it's using some of the data that we've already got in there. We need to convert this to use JSON and get the image, and then we also need to convert this that's populating this whole view to JSON too. So let's start with this image. And what I've done is, where are we? What I've done is lost VS Code. Here we go. what I've done is got the Flask application, and here's the route that deals with the images from a hash. So let's just quickly look at how that works. So what it does is it takes an image ID from the URL and goes and gets the image for that ID. So that'll be a timestamp, and we get all the timestamps when we populate the homepage, and we'll look at that later. And then what it does is it looks for the image data in Redis by running the get command. So what that is it's getting multiple fields from a hash. So we're asking it for from the key corresponding to that image ID. We're asking it for the image data field name, which is just a constant that I have. So there you go, image data. And the MIME type field name. And we need both of those, one for the image data, the other one to set the correct type on the response that we're going to send back to the browser. And all we do is we do get on that. Things come back in order. So the 0th or first field is going to be the image data, and then the index 1 field is going to be the MIME type. So here I just read that raw data back into a bytes.io, rewind the pointer to the start, and then tell Flask to send it out as if it was a file. And we set the MIME type to be whatever the other value that came back from Redis was. So the value of this MIME type field. And here I've got the Redis client set up so that it doesn't automatically decode values to strings, because I want to keep this as raw. So I'm having to, where I do want a string, like for the MIME type, I'm having to call Python's decode on that to get the string value back out. So that's fairly simple, and that's how it's working for our hashes. So I went ahead and wrote a JSON version of that, and let's just temporarily paste in this key name, and let's just call API Simon test and see what that picture that we just took looks like. So down there, we've got a Domo Kun figure in front of the camera. He's about, well, let's see how big he is. He's about that big. And we've taken a picture of Domo Kun, and it's quite a high resolution picture. We can do this. It's 4608 by 2592. So that's the picture that is stored in the JSON document. And that was base 64 encoded in Redis. It wasn't raw. So we need some different code to handle that. So what I've got here is this extra route that I've been messing around with, just called API Simon test, and we'll need to change this one to match that. But let's see how this works. So this, for the minute, takes a hard-coded key. And instead of get, we're now using JSON.get. And I now have to give it the JSON paths of what I want. So I want $image_data, field called image data off the document root. And similarly for the MIME type. And then what I get back is slightly different format. So I don't get back a sort of array of values. What I get is more sort of dictionary based. So let's actually run this command and see what it does. So let's grab the key. I want image_data and MIME_type. So we go here and run this command. Let's do .get, that's our key, and then I want $.image data and $.mime type. So if I go ahead and run that, what comes back, you will see that image data is quite big because it's a couple of megs worth of base 64 encoded stuff. And down the bottom here, you get $.mime type. So what happens is each thing that we've asked for now comes back as a property of a JSON object, and the value is an array, and then whatever it found goes in that array. So instead of just using simple indices into a list like we could with get, we now have to treat this as a dictionary and do MIME type 0 would be this value, and image data 0 will be all of this base 64 encoded stuff. So with that, what you see is we then get the image data like that. It's image data is the key name, and then 0 is the first thing in the array that comes back. And could probably have sent this out as a base 64 and then set the encoding to be like base 64 encoded image. But I wanted to try and keep this so that we didn't have to change the front end at all. So what I've done is decoded it here in the Flask server, and then it's the same process as before, and we just use a slightly different path to get the MIME type out. So this code here can pretty much go into this route here, and it's going to break everything for the minute. So the front end will stop working because the majority of these images are coming from hashes right now, and we need to change the logic for the front end to render the image from the JSON. So I won't change this right now. I'll come back to this. What we'll have a look at is how the homepage works, how we get to this, and then change that over to JSON. And that's kind of what I wanted to achieve today. So as I say, we'll break it and then we'll bring it back to where it was. So no actual new functionality, but just a more flexible data model. So this homepage, when you ask for it, just renders a template called index.html. In Flask, let's get rid of this folder for a minute. There's a templates folder. This is kind of standard Flask stuff. And in here, we've got a document index.html. So it renders this. I'm using the Bulma front end because it does a much better job of writing CSS and organizing things than I can without it. So that's what's giving us this nice grid. And I am then using a little bit of JavaScript to basically manipulate this document. And for each image that we get back from our server, we are rendering out the details of it. So down the bottom here, we're pulling in a file called app.js. This just means give it the path to /static, which Flask again understands to be this folder over here, static. So here's app.js. And what this does is, let's find the start point is it goes away and calls a route on the Flask thing called API prefix images. And this is just a constant values API. So /API/images. So what's underneath this front end that's powering it is, let's replace this with API images, is this data. So it's bringing back some information about each image in a JSON array. So what we need to do is to not have to change this front end, which I don't want to do, is basically pull this same information out of our JSON documents and create enough JSON documents that we've got, a screen's worth of data. At the moment, we've got 1 or 2 in there, and we don't have any more. So we need to change the thing that powers this route as well to get this data from the JSON documents. So let's go look at how that works. So we're not going to change any of the JavaScript or the HTML. We want the front end to stay as is. So what I need is, I've got a route here somewhere that, here we go, that gets how many images from Redis, or data about the images. So this data that you see here. And it does that using the search commands. So we search for everything in the image index, and I want a certain number of things coming back. I want the timestamp, the lux value, the MIME type, and I want to sort it by timestamp descending, and I want only the first 9. So that at the moment is only going to work on hashes because our IDX images only works on hashes. So what we're going to do first, which is the first step of breaking this so we can rebuild it, is we are going to destroy that index and rebuild it as a JSON one. So the easy way of doing that is find our index creation command here, and let us go back to Redis Insight over here. And actually, before we do that, let's do ft.dropIndex IDX images. And this is just going to drop the index. It won't delete the hashes. we could tell it to delete the hashes, but I'm going to keep them around for now. So we don't have an index anymore. So what should happen now when we do this is going to break because we stop Redis from understanding what that index is. So this query here has failed and nothing works anymore. So step one, break everything, success. So step two is put a new index in. So we'll keep it called IDX images. I need to change this. So this tells Redis search what type of data to index. So we're going to look for things that are in JSON documents. And we're keeping our prefix here because we're not changing the key naming thing. And then we need to replace these names here, which were field names in the hash, with JSON paths. And as we've kept things flat, it's pretty easy. We can just do $.mimetype, $.lux, and $.timestamp, and things stay pretty much as they were. But what will happen if we do that is the name of these fields in the index when we're writing queries will be $.mimetype and $.timestamp and so on. We can alias these. So let's do as mime type, and let's do as lux, and let's do as timestamp to try and keep things as consistent as we can. So we've created a new index there. There's not much to see at the moment because we don't have much data in there, but we can do ft.info on it, IDX images, and we can see what that tells us. So that tells us that we have 2 documents matching, which is the image that I created with the pie a minute ago and the image that I already had in there for test purposes. And we can see a sort of representation of what our index looks like. So we've got a couple of records in there. So when we refresh this, are we going to get any data? Like, yes, we've now got data back. So no change in the rest of the application. So we've swapped out a simple data model for a potentially quite complicated one. And we've not had to change any front end at the moment, or even the back end route. And I'm a little bit pleased with that because I thought I might have to. So we've got all of these values here coming back. What we can do now as well, if we wanted to, would be we could take advantage of, with hashes, everything is a string. So if you store a number in there, you can atomically increment, decrement it, treat it as a counter using Redis commands, but Redis will always output the value as a string. So we've got, lux and timestamp here are still strings. We could change these to be numerics because that's their actual data type now. So let's see if we can do that. So let's see what have we got here. So we've got doc.timestamp and doc.mimetype and doc.lux, and they all go into a dictionary. So we could just do like this, I guess. See how that goes. I think I've got Flask set up to auto restart. Yep, it's in debug mode. So over here it's auto restarted. Let's see what happens now. There we go. So now we've got some integer values in case our front end wanted to use those. So next question is, does the front end work? I'm expecting no. And why won't it render these two? Because the route that gets this image is still pointing at the hashes, and we don't have hashes for those keys. And if we did, the logic wouldn't work. So let's refresh this. And yeah, as you'd expect, we got some errors down here. We've got a wrong type. That means we're trying a hash operation against the key that isn't a hash. So we're trying it against the JSON key. But our metadata came through fine, and our alt text came through. So yeah, we're pretty close. So what we need to do now is take what we put into this Simon test and like make it generalized into this route here that deals with the hashes. So rather than this, let's do something else. So we need image data equals Redis client dot JSON dot get. Then we need the key. So let's steal that F string from there, which creates the key for us. And then we need some paths. And I think it's, well, I don't need to think about it because we already did it up here. So it's like a comma separated list of paths. So we want those paths. We want image data and mime type. So these again are JSON paths into the document of things that we need. And then we'll probably need to look at what comes back here because this is not going to work like that. So we'll worry about the not found case in a minute. But we've got here, I've had to change the path and I'm having to base 64 decode things. So let's do that. So instead of this here that was just getting that value out of the hash, which remember was binary safe, JSON now, JSON rules apply, we had to use base 64. Let's indent that correctly. So that will get the data. And this is going to fail because the thing looks different. So we need to use image data $.mime type 0. Because if you remember when I ran this command, we got back that object with a couple of arrays in it from JSON.get. So the shape of that has slightly changed. And that may well be it. And then we'll worry about this case in a minute. So over here, Flask has restarted again. Let's reload this. And still no images. So something, it's actually our 404 case has gone wrong here. So let's just comment this out for a minute. Worry about the sad path in a moment. Stick with the happy path. So there we go. So we've now got a couple of images of Domo-kun that were taken at different times. And this is basically working now. So we have swapped over our data model and we can add some more pictures. So let's go back to the Raspberry Pi here and run this again. And if I keep talking, it should just keep adding pictures, or I can explicitly, there it goes. Let's add something else into the frame. So I've added some other objects. So we should get a picture with something slightly different in. And then if I refresh this, there we go. So we've got 3 Domo-kuns and 1 Domo-kun with some shipping containers. And if we keep going, and I keep talking, and we keep changing things around so that we can see we are gathering different pictures. There's one with my hand in it. What you'll see is we eventually top out at probably 9 pictures eventually when we're at 7 right now. So we'll get 3 rows of these and let's put a mug in the frame. I don't know, it might have already taken 9 pictures by now. Well, not quite. 8. Let's see if it's going to take a 9th. There we go. So we've got a bit of a mug in the way of Domo-kun there. I'll get it out of the way. So we're taking pictures now, and what's happening is with a little bit of a code change, not very much. I'll turn the picture capture off so that we're not just going mad capturing pictures. We can now have a look here in the browser, and we can do a clear of that, look at everything. And you'll see these are all my old hashes. They're not being used anymore. We can actually go ahead and delete these if we want. Let's just get rid of those because they complicate things. And what you will see is all of the JSON documents. Let's pick one. Okay, that one was one of our test ones. It's got no time to live. So let's get rid of that as well, because that will never naturally clear down. That was another test one, no time to live. Let's get rid of that. So our JSON documents that were taken by the camera recently and that we haven't messed around with have got time to live set. So they're going to tick down and disappear and naturally age out of Redis. So if I get rid of all the rest of these hashes, and if you were doing this in code, you could do this more effectively with a search and then delete the results, or with a scan. But I'm just going to be semi-lazy and do it by hand here in the tool. So what you'll see is I should have, if I've done this fast enough, 9 or 10 images left that are all the JSON data type. So I've got 8 left because I deleted one of my my test ones. So now we should have only 8 in the front end here. And eventually the oldest one of these is going to expire in a few minutes, and then they'll start to disappear. And what you see is that they're looking after themselves. So what we've managed to do is, on the face of it, nothing, right? We've just broken everything and then put it back exactly how it was. But we've swapped out the hash data type, which is flat, for the JSON one, which gives us some greater flexibility to store more information about an image inside a single document. So we could go ahead and add random things to this in depth and so forth, but we can still maintain all of that atomic updates to it and the ability to retrieve just single fields. And the thing that we've had to change is that this is now base 64 encoded, because the image data has to be JSON safe now. And that's a JSON thing, not a Redis thing. So if you're just storing it in a Redis string, those are binary safe. If you want that to be interpreted as JSON natively, then it has to go through a JSON parser. JSON doesn't allow for that, so we have to use strings. So that's kind of where we are. What I'm going to do is stop this really quickly. And I am going to go back to VS Code here. And oh yeah, we need to tidy up this case as well. So let's just look at that. But I'm going to delete that route because we don't need it. I will update the documentation for this project so that this is showing that we're using JSON, not hashes. And what I'll do is I will create a branch for this, and I'll put the JSON version on a branch, and I'll link to that branch from the main branch, so that when you go to this project, which you can find here, you'll be able to see the hash stuff and then swap over to JSON if you want to. And Deshaun says, so 2 things. I used to work with Deshaun. Hello. And also, you're supposed to be on holiday. It's Independence Day. Why are you watching coding live streams? But thank you very much. Deshaun also does quite a lot of live streaming, so you can look him up. I don't know what the best way of looking him up is, but if you want to post in there, Deshaun, I'll let people know. So yeah, where were we? We've got to finish this thing. So we've got a broken what happens if there isn't anything. And let's start Flask back up again and see if we can do something with this. So let's just it's fun project. I don't have to use the debugger. We're just going to use print. Let's see what happens if I request an image that is valid. Hopefully that one's still there. Ooh, no, we get none type is not subscriptable. maybe it's gone. Maybe it expired from Redis. Well, that's interesting. So maybe we can just get away with if image data is none. I'll probably do it. Then 404 it. So there we go, 404 it. Okay, so that's hopefully fixed that. And then if we refresh this, we have no images because they probably all aged out because of that time to live. So if I go and refresh this, yeah, we have nothing. So now we fixed the sad path, we better make sure the happy path works. And the way to do that is start the capture thing up on the Raspberry Pi again, keep talking so that the sensor goes off, or I can snap it. And it's created a new image. Let's see what we've got here. We've got a new image. We've got data for that. And now hopefully when we come back to here and refresh it, oh, we've got a couple of them by now. But do we have the actual images? Oh, yeah, there we go. They're just taking a second. So we've got the actual images. So things are working again. So we've got that. That's okay. If we expand this out to an image that is valid, great. If we change that to a timestamp that probably isn't valid, we now get a 404. So we're back to where we were. So in this, what, about hours worth of live stream, we have basically broken something and put it back together again, exactly how it was. And was that pointless? Well, hopefully not, because we've got a JSON schema underneath it now. So if we want to add more complicated things in here, then we can do. And it just gives us a lot more flexibility than the hashes. I'm not saying it's better, it's just different. So you've got both options. So what I will do is I will create a branch for this, and we will be creating lots of images there. Let's stop that and go to the laptop here, and I'm on the main branch. I'm also going to have to retrieve that capture code back from the Raspberry Pi and commit it, but let's just do git checkout minus the JSON data model. And what I'll do is this. What I'll do is off screen, I'll get the capture script that goes with this and update the documentation, and then update the main branch. So there's a pointer to this branch. So then this project will have both a JSON and a hash version of itself. And again, if you want to grab this, you can get it here. It might take me a couple of days to update, but I am done with the other things that I've had to do. So I've got some time for these projects. So yeah, that was about it for today. The one thing that I did say I'd come back to is Discord. So if you are interested in chatting with us, and especially about this show, we have Discord channel at discord.gg/Redis is the server. Internet of Things is the channel, but there's all sorts of other channels. There's loads on here for all of our different courses and technologies. And like I said, there's stuff like self-promotion. So if you've got a project or something that you're doing, we would love to hear about it. And you can find it all there on Discord. The only other thing would be, if you're interested in this sort of content, have a look at Redis University. And if we go here and go to the university, what you'll see under courses is we have some courses that are kind of interesting to what we've been doing. So we've been working with Python. Redis for Python developers here covers how to use Redis from the Python language. And then we've also made use of JSON. So we've got a course here for indexing and storing JSON. And when we were doing hashes with indexing and search, this other course, IU 203, querying, indexing, and full text search, covers that. The mechanics are pretty much the same. It's just the underlying data structure that differs. So yeah, that's about all for today. I will be back at, I'm not entirely sure when in the future, but soon. I'll be back soon with a new project. It's time to do something different in the IoT space on this channel. And like I said, the supply chain has eased up a little bit. So we've been able to get hold of a few Raspberry Pis of various models. I've got a Model A Plus, which is the smaller one. And we've got a couple of the sort of relatively big, I mean, they're still credit card sized, but relatively big 8 GB Pi 4s, which are interesting for running actual Redis servers on. So hopefully I can think of something interesting. And if you've got any ideas, best place to come talk to me about them is Discord. So hopefully we'll see you there at some point. But I will leave you for the rest of your day. And if you are celebrating Independence Day, if you're in the US, happy Independence Day. Go and do something more interesting than watching a live coding stream with the rest of your day. But yeah, take care. See you on Discord. Thanks, everyone. Bye.